Hi, this is Missy McTaggart. In this video, we are looking at probably the third or fourth lesson in integration, something called definite integrals. So it's just building on all the stuff we've done already, but we're adding in new steps at the beginning. So what a definite integral is it means a wee bit different. So you can see there's now values at the top and bottom of integration sign. These are called our limits. These are numbers that we substitute in that give us a definite value at the end. And the way we do this is by simply we integrate our thing as normal and we get f of x, and we rewrite this with square brackets and we put our limits at the right hand side. I don't know why, this is just a notation, okay? And then what you do from there is basically you substitute in to your integrated answer, you substitute in the value for b, take away the substituted value for a, alright? And then here is my example here. Now I'm going to do something in the first example which I maybe won't do in the others, just to explain what's going to happen with our c value here. So what we do is we integrate as normal, but we put a square bracket first. So this becomes 3x cubed all over 3 plus c, and we put a 4 and a 1 at the end. Then what we do is I'm going to simplify that, so that's just x cubed plus c from 4 to 1. So you substitute in your first value, which gives you 4 cubed plus c, take away, substitute in your second value, which is 1 cubed plus c, and then what happens is we have 64 plus c, and then that becomes take away 1, and then we've got a take away c. So do you notice what happens with the c's? They kind of cancel out, and you're just left with the answer of good old 63. So it's worth noting that the c and the c disappear. The c take away c causes the c's to disappear. So only when you're asked to integrate with numbers, so definite integrals, like a 3 and a 2 at the top and the bottom, you don't need to put in the plus c bit. You won't get marked down for it. So for example, at this line here, if you don't put the plus c in, you will not get marked down. It's assumed you understand the c disappears. The c is included in any other integration question as long as you don't have these values here to deal with, okay? So we can forget the plus c, but I'd always like to just do it in my first example. Okay, example 2. Let's integrate. So we're going to integrate. This becomes 4x, increase the power to 4, divide by the new power, which is 4. Integrate the number 1 just gives you x, close your bracket, and we put 2 and negative 1 at the side. I'm going to simplify this before I sub in, so it's x to the 4 plus x. And then we're using 2 to negative 1. So in the first bracket you have 2 to the power 4 plus 2. Take away negative 1 to the power 4 plus negative 1. 2 to the power 4, I use my fingers, 2, 4, 8, 16. 16 plus 2 is 20, so the first bracket is just 20. Take away negative 1 to the power 4, it's an even power, so it's going to be positive 1. And then that's just take away 1, so that's just a big old 0 in this square bracket. So your answer is just 20. Okay. Let's get a bit trickier. So this is one we've got to break it down before you can integrate. So we're still doing the integral from 3 to 0. This will be x over x cubed plus 5 over x cubed dx. Still not ready to integrate, so we keep the 3 and the 0. This is because 1 over x squared, so we'll write x to the negative 2, and then that'll be 5x to the negative 3. Now I'm ready to integrate. So out come the square brackets now and only now. Right, increase your power, x to the minus 1, divide by minus 1, plus 5x to negative 2, divide by negative 2. Close your brackets, put on your 3 and the 0. Right, before I can even think about subbing in the 3 and the 0, I have to tidy this up and write everything with positive powers. So that negative 1 can come to the top, but the x can go to the bottom and just be written as that, okay? Because I'm essentially dividing by minus 1, so I get minus 1 on the top. This plus negative will become a negative. 5 will stay on the top, but the 2 will go down there. So the x to negative 2, will become x squared down there. Right, now I can plug in my numbers. So if I plug in 3, I have minus 1/3 minus 5 over 2 times 3 squared. Take away Now when I plug in the 0 here, I don't actually have to do what I'm writing just now. When I plug 0 into either of those terms, they both become 0, so it's safe to say that that end bracket is 0. Subbing in 0 is lovely because it just gives you a bracket of 0, but you have to write it. You have to show that you knew that bracket became 0. You can't just not write anything, right? Because then it looks like you've just missed the whole second bracket. Okay, tidying this up, we have minus 1 over 3 minus 5 over 3 squared is 9 times 2 is 18. I can basically drop that second bracket now because it just gives us 0, but this will give us, without a calculator, I'm going to turn that all into 18ths. That is minus 6 over 18, because I've just times everything by 6, minus 5 over 18. Oh, I don't need that 0 anymore, I can drop it, but I've written it now. So this gives us negative 11 over 18 for our answer. Okay, my last example like this before I show you one more little style of question. So we have this. So we have the integral from 8 to 1 of 1 over 3. Now this is a cube root of x, so I've not written that very good. So cube root of x would be x to the third, but it's coming to the top, so negative 1/3. And I'm just going to leave that as all over 3. So this is what we are integrating. So when we integrate this, we're adding on 3/3. So we're adding on 1, which is 3/3. So it gives us x to the 2/3 all over 3 times, I'm dividing by this new power of 2/3. I haven't done any like that in my videos so far. Now, just to help you out, I'm going to come to the side and do 3 times 2/3 is the same as 3 over 1 times 2/3, which is 6 over 3, or they can cancel, so that's just a good old 2. So the bottom line becomes a 2. I'm going to rewrite this using thirds though, so 2/3 would be the cube root of x squared. Remember, the top number stays where it is, the bottom becomes the root. And then that denominator was just a big old 2. I'm going to plug in the numbers 8 and 1. Which leaves me with the cube root of 8 squared all over 2 minus the cube root of 1 squared all over 2. Cube root of 8 is 2. Square root is 4. Divided by 2 is 2. So I'll say that again. Cube root of 8 is 2. 2 squared is 4. Divided by 2 is 2. Take away. Cube root of 1 is 1. Square root is 1. Divided by 2 is 1/2. So you've got 2 take away 1/2. Which you can write as 1.5, 3 over 2, 1.5, whatever you like. So I'm just going to leave it as 3 over 2. So 3/2. And my final question is different. This is it makes like a little equation and we have to work out what a was. So we're just going to pretend and integrate as normal. So we're going to integrate, 1 becomes x, 2x will become 2x squared all over 2. I would then put an a and a 1 at the end, but what I'm telling you is that when I integrated using this unknown, which looks a bit like a 9, when I used that unknown of a, and the value of 1, I came out with an answer of 4. So I'm going to rub out this, and I've literally formed a little equation. So let's break this bracket out, these brackets out. So sub in the a, so I've got a plus, oh, I've done it again. These 2's will cancel, so I'm just going to ignore them at this stage. So that would just be 1a plus a squared. And then I would do take away, plug in the number 1, be 1 plus 1 squared, and this all equals 4. I can see where this is going, so I'm going to change my order a little bit. So a squared plus a. This bracket just gives me 1 plus 1, which is 2. And then I have to take it away, so take away 2 equals 4. Are you starting to see the trinomial up here? So I'm going to take the 4 over, which gives me a minus 6. 2 values that multiply to minus 6 and add to 1 are a plus 3 and a take away 2. So at this point, a equals negative 3 or a equals 2. Now if I take you back to the very top of the question, a was my upper integral, which meant A has got to be bigger than 1. So I'm going to put a line through this one and say that A is greater than 1. So my final answer is A equals 2. Please remember, if you're discarding something, say why, or write the word discard or not possible or disregard. Don't just put a line through it. Don't score it out that we can't read it. Please, please, please make your conclusion nice and clear, okay? A line through it is just about enough, but we want to see why you've done that you've noticed that it's an upper limit. So I've only done one of them, but there's not that many out there in past papers. If you've access to a textbook, there'll be quite a few. It's not always a trinomial, sometimes it's a plain old equation. But yeah, give them a go. There are some questions on this slide if you want to practice some definite integrals that I used in my class. That's the answers in red if you want to pause the video and try them. You might have to zoom in because some of the fractions are a little bit small, but they do get progressively more difficult as you work your way down. Thanks for watching this. Good luck. Bye bye.